Hi, Mr. Heffernan here, and here is a short video on the scientific units, or the MKS units. So in the MKS units, or the scientific international units, use the second for time, Kelvin for temperature, candela for luminosity, kilogram for mass, the coulomb for electric charge, the mole for the amount of particles, and then the meter for length. Okay, so the scientific international units, or the international units used for science, are based on the metric system. The SI units were invented in France to compete with the English imperial system, which was considered harder to use, and they just wanted something that was easier to work with. MKS. In physics, we use the Metre-Kilogram-Second SI units system. This system is used in other sciences and fields of study as well, and most units are based on the MKS system. Okay. CGS. In chemistry, sometimes they use the Centimetre-Gram-Second system. But beware, this is not the most common system. MKS is the system mostly used. Fundamental lengths, or units. The main three fundamental units are the meter for length, kilogram for mass, and the second for time. Other fundamental units are the coulomb, C for charge, Kelvin for temperature, mole, and for number of particles, and the candela for luminosity. Okay. Derived units. All other units are combinations of these fundamental units. So, for example, if you're measuring electric current, which is measured in amperes, 1 ampere is actually just 1 coulomb per second. So the coulomb fundamental unit and the second fundamental unit. Okay, so here's just a list of the fundamental units, which will be on the presentation if you want to download that later. But not that you really need to. But as you can see, for example, area is meters times meters, meters squared. Density is kilograms per cubic meters. The Newton, which is the scientific unit for force, is a kilogram times a meter per second squared. Energy, a joule, is a kilogram times a meter second per second squared. And a volt is a kilogram times a meter squared per coulomb times a second squared. So basically all these different things that we measure in science are, all these units are derived from fundamental units. Okay, so when you're doing science, most of the time when you're doing science or solving problems, you will need to use the SI units to ensure you get the correct answer. This may require using special conversions. For example, to convert between meters per second and kilometers per hour, we use the number 3.6. 108 kilometers per hour divided by 3.6 is 30 meters per second. But if you want to take a number and go back to common units, 5 meters per second times 3.6 is 18 kilometers per hour. So in summary, the SI, the Scientific International Units, was invented in France, not by Yoda, and we just say it backwards because it was written in French. Okay. And the backwards for English, that is. And then the MKS system, this is the main SI unit system, the Metre-Kilogram-Second system. The reason I guess they picked the kilograms because the gram was just too small for normal masses. For example, human beings are probably around, like 70 kilograms. You wouldn't want to go around saying, oh, you're 70,000 grams. That's a huge number. Okay, and then the CGS system, it also sometimes is used, has its own derived units. For example, for force, in the CGS system, they use the dyne. A dyne is a gram times a centimeter per second squared. And it works out to be exactly 1/10 millionth of a Newton. So you need 10 million dyne to make a Newton. And of course, you got the imperial system, where 2.2 pounds of force is the same thing as 9.8 newtons of force. And so it can be a little tricky converting between them. And that's it. So I hope this gives you an idea about the SI units, and in particular the MKS system.